Okay, so now we're going to solve this question right here. And it's basically saying consider a 0.5 liter solution that is prepared from acetic acid. And it's giving us in molar 0.4 and its conjugate base, which is 0.3. And we have Ka, which is 1.76 times 10 to the negative 5. And it's asking us two things. So one is to calculate the pH, and then it's calculate the pH when you add NaOH, this much, to this solution. So seems pretty easy. First thing that I like to do with these types of problems is just automatically write the equation for a buffer. This pH of a buffer has its own separate equation. You don't need an ICE table for this, which is why I always love doing these. But yeah, very easy to learn in my opinion, the buffer equations. But anyways, this is the equation. pH equals pKa plus log of base over acid. So we're going to identify which one is our acid and which one is our base here. So we know that this, we have this is the base, this is the acid, and this is also the base. So yeah. So the first thing that we're going to do is we're going to get from Ka to pKa. So we know that pKa is the negative log of Ka. So it's going to be negative log of 1.76 times 10 to the negative 5. And that gives us a pKa value of negative log of 1.76 times 10 to the negative 5. That gives us a pKa value of 4.75. Now what we're going to do is we are going to calculate the moles. So I'm just going to put number 1, then number 2. We're just going to need moles of base and acid. So for the acid, it's going to be moles times liters. That's going to give us the moles of the acid. So that's going to be 0.400 moles times 0.500 liters. And this is going to give us 0.400 times 0.500. We're going to have 0.2 moles of acid. And then for the base, and we know this is a base because it has a negative charge right there. So yeah, it's going to be 0.300 moles times 0.500 liters. 0.300, we have moles 0.15 moles of the base. So this is pretty good. Now that we have our pKa, we have the moles of the acid and base. pKa, moles, acid, we're good to plug this into that equation. Let me just change the color. I'm gonna zoom in a little bit over here. So it's going to be step 3, which is pH equals 4.75 plus the log of base, which our base was 0.15 over 0.2. So I'm just gonna do this math first. So it's going to be log of, so it's gonna be 0.15 divided by 0.2. That's going to give us the log of 0.75. And then the log of 0.75 is negative 0.125, and it's going to be 4.75 plus that, and that's going to give us a pH of, let me do the math, 4.75 plus negative 0.125, that gives us a pH of 4.63. This is the initial pH, by the way. Initial. Okay, so let me zoom back out. Sorry. Let me just, okay. Now we have to find the new pH. So it's asking us to calculate the pH of the buffer when we add this amount of NaOH. So what we know about NaOH is that it's a base. So what's going to happen to the initial pH is that it's going to increase, because a base increases the pH and then an acid decreases the pH. So with that being said, what we're just going to do is pretty easy. We're just going to find first the moles of this, and then we're just going to literally plug it right back into this. It's going to be pretty easy, to be honest. So let's just head right to it. So now step 4 is going to be to calculate moles of NaOH. So that's going to be, oh, it's already even given. Actually, what we have to do is, we don't even have to convert milliliters to liters. It's all given. This is a nice example. So 0.100 liters times the 0.200 molar of NaOH, and that's going to be 0.100 times 0.200. That gives us 0.02 moles of NaOH. So now that we know that, we're just going to plug this right back into the equation. Now, one thing to keep in mind, since we're adding an acid, that means that the acid, oops, sorry. Let me take that back. Since we're adding a base, oh my God. We're adding a base, that means the base is going to increase and the acid is going to decrease. So this is going to look something like this. So the new pH is going to equal the same pKa value, which is 4.75 plus log. And now we have the original moles of the base, which was 0.15, plus the new moles of what's being added. Because since we have a base, right? We have a base, and we're adding a base, we're going to have more of the base, right? That makes sense. So it's going to be 0.02 over 0.2 minus, since the acid, right? Since we're adding a base to this solution of acid and base, since we're adding this, we're going to have less acid. So it's going to be minus. So we know that the original moles for the acid was 0.2, 0.2, 0.2. And then it's going to be minus the moles, right? Nothing has changed. 0.02. So I'm just going to do the math in the parentheses first, as always. So 0.15 plus 0.02. Which is 0.17 over 0.2 minus 0.02, which is 0.18. And now we're just going to divide that. 0.17 divided by 0.18. That gives us the log of, maybe let me actually just, bring this, put this a little smaller. I don't know why it's so big. I'm running out of space. So that's going to give us, let me zoom in actually, log of 0.94. And when we put that, 0.94 log of that is going to be negative 0.02. I guess you can do 7. And then it's going to be 4.75 plus that. And that's going to give us the new pH, which is going to equal, let me do the math, 4.75 plus negative 0.027 gives us a new pH of 4.72. And this is our final pH. And this makes sense because, like I mentioned before, a base increases pH while an acid decreases the pH. And guess what happened to our original pH and our final pH? It increased, it went up.